Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Welcome to Lesson 14, Checking for Identical Triangles. Classwork. In each of the following problems, determine whether the triangles are identical, not identical, or not necessarily identical. Justify your reasoning. If the relationship between the two triangles yields information that establishes a condition, describe the information. If the triangles are identical, write a triangle correspondence that matches the sides and the angles. Okay, so here we go. So here is the first example. What is the relationship between these two triangles below? And I have this is one mark right here. It's hard to see in this video, but this has one mark and this has one mark. So ZW, I'm just going to mark everything down here. Side ZW is congruent to side XY. ZW is congruent to XY. And then I can also see that, it's hard to see in this video, but this was 2 marks. And this is 2 marks. Which means side ZY, this side, is congruent to side XW. So I have 2 sides congruent to 2 sides. So far I have a side and a side. Over here I have a side and a side. But as you can see as well, if I move this triangle over here, see where it was? YW. So if I move this over here and move this over here and separate them, and then I label these, this was Z, this came from here, this was W, and this was Y. Okay, so now that I've labeled that, let me put those back. See how the W, the Z, and the Y are all in the same locations. So this is the triangle ZWY over here. And now I've labeled this triangle, so if I move this over back to where it was, W, Y, and X are in the right labeling. So they were together like this. So as you can see, if I move these apart, YW is equal to itself. They share a common side right here, which is another side. So these two triangles are identical by side, side, side correspondence. And my triangle correspondence is going to be triangle W, Y, Z corresponds to triangle. Now W is here. Now you need to be careful with the way you label the next one. You can't call WW when we're talking about this, because if I take this and I rotate it around so it's in the same position as the orange triangle, and I lay it on top right here, what corresponds to W? Well, it's upside down, but it's this Y. So it's going to be Y. And then what corresponds to W, or I'm sorry, Y. So W corresponds to Y, and then Y corresponds to this W here. So that's W. And as you can see, Z, X lands on top of Z. So W, Y, Z corresponds to Y, W, X. Okay, so hopefully that was clear to you. I'll rotate this back to the way it was. Another way you can check this is YW is this side right here, and it corresponds to this one, but it's in reverse direction when I rotate it. So Y goes to W and W goes to Y. So that's what we have here, WY, YW. Okay, so anyhow, that is example 1. And now we're on to exercises 1 and 2. So now See if you can do what I just did. Pause the video and see if you can identify if these triangles in numbers 1 and 2 are identical, not identical, or not necessarily identical, and state why. Okay, so I'm going to take a look at this, and I see angle Q here has one arc. Angle S has one arc. So I'm going to say angle Q is congruent to angle S. Forgot my little angle symbol there. Angle Q is congruent to angle S. QT, side QT, is congruent. QT, I'm going from the angle that's marked up, is congruent to ST. So that is a side. Let me change colors for my labeling. Use black. So this is an angle that is congruent to an angle. This is a side that's congruent to a side. And remember, when two triangles are touching, that the sides are shared, therefore it's the same length in both triangles if I separate them apart like I did up here. So I could say side, let me go back to this, side TR is congruent to itself. So that is also a side correspondence. So what do we have here? We have a side, we have a side, we have an angle, and the angle is not in between. It is not the included angle, because it would have to be this angle up here to be included in this angle. Right here, these two sides would have to form the included angle, and that does not happen here. So be careful. It is not SAS. It is SSA. All right, so now I have to justify something here. What do I say? The triangles are not necessarily, they could be, they're not necessarily identical. Okay, since we have the SSA, they could be identical, but they might not be. We can't say for sure. It's not enough information. So the triangles are not necessarily identical. There is a correspondence of triangle QRT. So if I name the first triangle QRT, there is a correspondence with the other triangle, and Q goes to S, R goes to itself, and T goes to itself. So triangle QRT corresponds to triangle SRT if it's just a flip over the side TR. But we can't say for sure that QR is congruent to RS and that these angles here are congruent. So we have to say the triangles are not necessarily identical. Okay, here's page 2. Problem number 2. Are the triangles identical? Justify your reasoning. So I will start by showing that angle E is congruent to angle G, okay, because they both have one mark. EG is assumed to be a straight line. So if this is a right angle, that's 90 degrees. And a straight line is 180 degrees, so therefore this must be 90 degrees as well. So, angle. And I can't just call it F because there's 3 angles here. There's angle EFG, the 180 degree angle. There's angle EFH, which is 90. And there's angle HFG, which is 90. So I have to name them with 3 letters. So angle EFH is congruent to angle GFH. Okay, and then I have this side congruent to itself. HF or FH is being shared, so they're equal. Okay, so I have HF congruent to itself. So now when I label these, this is an angle, this is an angle, and this is a side. This is an angle, already labeled this as an angle, and this is a side. So that is angle, angle, non-included side, and therefore the triangles are identical. By angle, angle, side. And then the correspondence would be triangle, and the way you first name the first one does not matter. I'll name it EFH. Triangle EFH corresponds to triangle G. E goes to G. E is congruent to G. And then I went to F, so I have to go from G to F, and then up to H. And that's number 2. Okay, number 2. Here's an example number 2. Now notice these two triangles. Well, I need to explain something about this. So if I draw a line segment, I don't want too thick. If I drew this right here, okay, that is a straight line. And if I drew another one right here, that is a straight line. I don't want it that thick. Okay, so if that is a straight, those two are straight lines, then from your prior math courses, you should realize that these are vertical angles, and vertical angles are congruent. So in labeling my givens, I know that side CO is congruent. CO is congruent to DO. Okay, because of these two marks here and these two marks here. Angle A, or side AO, is congruent to side BO. Okay, so I'm going to label these over here. This is a side, this is a side. All right, and then angle AOC is congruent to angle. And since I started with green, I'm going to start with green over here. That's why labeling with color is always handy. So if you have colored pencils, this might help you. So you start at B, and you go across the greens, because I started at A, went to O, and then up orange. So I went green, orange. So if I go green, orange, I would name that BOD. And so therefore that is an angle. So if I labeled this, this is a side, this is an angle, and this is a side, and it's the included angle. This angle is formed by the green side and the orange side, so therefore it's included SAS. So the triangles are identical by SAS. And the triangle correspondence is, some triangle corresponds to some triangle. If I name this AOC, A corresponds to B. I said corresponds, not Cortana. Stop it. A corresponds to B. O corresponds to itself. And C corresponds to D. So triangle AOC corresponds to triangle BOD. Okay, page 3. Exercise 3 and 4. So again, an exercise. Pause the video, see if you can do these on your own, and then come back. All right, here we go. So this is ABO, and this angle B right here is congruent to angle D. And I'm just going to list all the congruences. Angle B is congruent to angle D. And so therefore that is an A for an angle, and that is an A. And then I'll move on. Side AB has a marker. Actually, it's 2. And side CA, or CD, I mean, CD has a mark. So, side BA is congruent to side DC. Okay, and so therefore that is a side. And then we have a straight line here and a straight line here forming vertical angles. right here. So angle BOA is congruent to angle DOC. So angle BOA is congruent to angle DOC. So that's also an angle. So I have an angle, but it's not, it's a non-included side. In order to be an included side, for those who are still struggling with included, the side would have to go from one marked angle to the other. So the included side would be BO, not BA. So it's a non-included side. So that is angle, side. So I would say the triangles are identical by angle, side. And the triangle correspondence will be triangle ABO. And A corresponds to C, B corresponds to D, and that leaves O last again. So triangle ABO corresponds to triangle CDO. Okay, number 4. All right, so we have angle A. Actually, angle A and B are congruent because they all have just one mark. But I will color code these. Angle A would correspond to angle C. So angle A is congruent to angle C. Angle B corresponds to angle D, and angle B is congruent to angle D. And then in the middle here we have vertical angles formed by two straight lines. So I can then say angle AEB is congruent to angle CED. And if I label up this is an angle, 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 so it is okay, so even though we have the angle theorem, two angles, and actually it's a third angle as well, we would say not necessarily identical triangles. Okay, and let me explain why. If I were to extend this side all the way out to here, and then I took and I extended this side all the way out here, okay, and then I created a third side from here down to here, and I made those angles congruent, and so now this is D and this is C. Notice how large this triangle is compared to this one. This angle is congruent to this angle, this angle is congruent to this angle, and this angle is congruent to itself, but really these two triangles are definitely not congruent. So just because we have three angles congruent to three angles does not necessarily mean the two triangles are congruent. We could expand the side lengths and not change the angle measures. Okay. All right, page 4, exercises 5 through 8. In this triangle, we're told that angle M and angle N are right angles. So angle M is congruent to angle N. We're told that side MP is congruent to side NP. Okay, and then we have try that again. Don't know what happened. This side right here is shared. Okay, so OP is equal to itself. All right, so now when I label these, I have an angle. I have an angle on this one. I have a side. I have a side. And this is a shared side, so they're congruent. So this is an angle and two sides. So that's SSA. But with a 90-degree angle. So with the 90-degree angle, SSA confirms that the triangles are identical. So my triangle correspondence is going to be triangle MOP is corresponding to triangle M goes to N and then OP. Now there's another name for this, so let me erase everything in here now. OP is a hypotenuse. This is the hypotenuse, and this is a leg, and this is a leg. So we have a right triangle. Opposite longest side is the hypotenuse. So whenever we know that the hypotenuse is congruent to a hypotenuse and a leg is congruent to a leg, that is also called the HL theorem, hypotenuse leg theorem. Okay, should have learned that in, I believe, 8th grade. Or I should say you will learn that in 8th grade, not should have. All right, so HL, hypotenuse leg. So there, you learned it here. All right, number 6. Are the triangles identical? Justify your reasoning. Well, before I get started, I am going to label that there is an identical shared side right here. So it's congruent to itself. So we have FK. Okay, I guess that's an E, not a K. FEDC. All right, so FE is congruent to FE is congruent to DE because of these marks. CE is congruent to itself right here. And then we have this angle here congruent to, so angle FCE is congruent to angle DCE. So if I label all of those, this is a side, this is a side, and this is an angle. Okay, so it's side, side, angle. But they are not, that's acute. So the triangles are not necessarily identical. Okay, because angle FAE or FCE, angle FCE is acute. Okay, page 5, number 7. Are the triangles identical? Justify your reasoning. All right, so we have angle S congruent to angle T. We have a shared side. So that means RW is congruent to itself. Alrighty, and then we have this angle here marked. So angle SRW is congruent to angle TRW. Okay, so if I label my triangle up, here's an angle, and this is a side. So it's AAS. So since we have angle, angle, side, then the triangles are identical by AAS. And the triangle correspondence is triangle SRW. And again, the order does not matter in the first one, just have to follow what you put corresponding. So S corresponds to T, so T has to come first, then R, then W. Okay, number 8 says to create your own label diagram and set of criteria for a pair of triangles. Ask a neighbor to determine whether triangles are identical based on the provided information. So that is obviously an activity that you have to do in class, so I will not do that in this video. Okay, on to page 6. That is the end of lesson 14. Review the lesson summary and go to your problem set.